Hello everyone. So the DLD video here we're going to talk about lesson 2.3, which is about slope. So we're going to find the slope of a line is the ratio of change in the y coordinates to the corresponding change in the x coordinates. So we're comparing y to x in this ratio. Alright, so guys, slope isn't anything that is new to you guys. You've found slopes. So if you've got a line drawn on a graph, again, the slope is the difference in the y values, so y2 minus y1 over the difference in the x values, x2 minus x1. So that is the formula for slope. So just use two ordered pairs, or again, we can also use the idea of rise, change in y, over run, change in x. So we can also use that if we've got a graph. We can use rise over run. So both of those ideas should be familiar to you. Alright, so kind of here's a summary. You can hang on to that box. Find slope using coordinates. So here we've got to use the formula. Find the slope of the line that passes through. Those are our two coordinates, okay? So what I typically do, I call one point x1, y1 when I'm working with linear equations, and the x2, y2 would be my other point. So slope, again, y2 minus y1, so 5 minus y1, 3, over x2, which is 2, minus x1, negative 4. And I always use parentheses when I substitute in these values because as you can see here, well, 5 minus 3 is 2, over, this becomes 2, double negatives become plus, 2 plus 4 is 6, so the slope of this line is 1 over 3, 1/3. Okay, so that's slope. And again, slope, guys, we should be using fractions for slope. Should not use decimals. You should use a reduced fraction when you're talking about slope here. All right. So 3a and 3b, you guys can pause and find the slope of both of these lines. And then once you're done, just come back to the video. And so if you've finished that now, again, call one of these points x1, y1. It does not matter. I just always go left to right. But it really doesn't matter. I could switch these and I would get the same slope. So y2, 5 minus y1, negative 3. So I got the double negative situation there. And then x2, 3 minus x1, 1. So this becomes 5 plus 3, 8 over 3 minus 1, 2. So that is 4. 8 over 2 is 4, or 4 over 1. So that's the slope of this line. And then if you did 3b as well, you should have. If you didn't, pause and go ahead and do it now. But again, one point 0.1, the other 0.2. So y2, so negative 9 minus y1 is 11 over x2, 24, minus x1, negative 8. And so negative 9 minus 11 is negative 20 over, that's 24 plus 8, 32. And so this is a fraction we need to reduce. This one might be kind of tougher, but just use the GCF or any common factor that you can use to reduce it. You could use 2. 4 also works. So 4 is the GCF. So 4 goes into 20, 5 times, and 4 goes into 32, 8 times. So negative 5 over 8, that'd be the slope of that line. Alright? So that's using the formula. Okay. Find the slope of the line shown at the right. Let's use the idea of rise over run. And so to do that, you've got to look at, you've got to be able to identify points, okay? And again, points on a graph are places where the line goes, straight through a coordinate, all right? And so you can use any of these 3 points, and the idea of, again, rise over run is what we're thinking of. So, to kind of save some confusion, I mean, it seems like a lot of people, when they look at the graph, they might miss the sign of the slope, whether it's positive or a negative slope. clearly you can identify this to be a negative slope, but then if you were to try to write the equation of this line, you might even write it as a positive for whatever reason. I don't know, folks tend to mess that up when we're doing rise over run. So the way I always do it, I always run to the right. So I start at my point to the furthest left. Okay, so I would start at this point here. And now I'm going to determine whether my sign is going to be whether I go up or down. I go down 1, 2, 3. So I went -3. I went down 3. And I'm always going positive x direction. So I go 1, 2 to the right. So my rise, I didn't actually rise. I went down 3. So I went -3. Over run, I always go to the right 2. So my slope here is -3 over 2. Alright, so again, I always just start at the point furthest left and go to the next point that I see. Okay, and so I'd encourage you guys to do that as well. If you're looking here at this graph 4a, you guys go ahead and practice it. This one's kind of challenging to find where actual points are, because there's some that are really close to going through the corner of those boxes. Like this here, I don't think they intend to be a point, but if you used it, that might change your answer a little bit. That one just seems a little low to me. So the two I would use are these ones right here. Those seem to be the most that are, most clearly cut out to be. And again, I always start at the left. So I would, in this case, go up 1, up 2, up 3. So my rise is 3. And I'm always running to the right, so this is always going to be positive. 1, 2, 3, 4, 5, 6, 7, 8. So 3, and then I ran 8. So 3 over 8 on this one. This line I think is a little easier to find points here, and I would consider this a point as well. So again, if we're going rise over run, I always start left. So I go down 1, 2, 3, 4. So that's a -4, down 4, and then right 1. So -4 over 1, or -4 would be the slope. Alright, so your homework for the DLD, we're just working with slope, 12 to 21, 23 to 38 there on page 80. So that can be found in your textbook. And thanks for watching, everybody. Make sure you guys have a wonderful weekend. See you all back on